Okay. Hello. Well, good morning. Yeah, so in the follow-up of the easy overview, I'll talk a little bit about how it is to contribute software to easy, to add new software, kind of what the experience is as someone who's adding new software, and what happens a little bit also behind the scenes, and what the processes are for this. So also a little bit about me. There's a bit of delay. Oh, there we go. And similarly to Lara, I'm also fairly new to this. My background is in evolutionary biology, so I was something completely different. So I think I was more in the camp of the people making package managers crying, then moved on. So I joined the University of Groningen, the HPC team, in September 23. Before that, I was working as a scientific programmer, also in the University of Groningen. Before that, I was doing their PhD in evolutionary biology, and now I'm as part of my role, I'm attached to the EasyBuild project and in the context of multi-xScale. So that's a little bit of my background. So the point of this talk is to go over how it is to contribute to Easy. In particular, I want to focus on the software layer, even though, of course, elements of all of the other parts of Easy are relevant to this, of course, but I'm going to focus specifically on what it is to add software to the software layer, to get new applications. So in the software layer, well, as you've heard from Lara's talk, the idea is when we say adding software to the software layer, it really means, okay, we need to build, install, and make available a new piece of software that is built for all of these CPU targets. And we're actually just starting. It's almost to the point where we're kicking off building a lot of stuff for Zen 4, but these are our CPU targets we have. And we manage this, excuse me, on the through this GitHub repo, easy/software layer. And this is also is going to be the interface of how you add things and how you command things to be built for Neoverse N1 and so on and so forth. Okay, so a little bit of an overview of what is already there. So I counted this, I think a couple of days ago. I don't think the numbers changed, but it might have a little bit. By now we have 577 not software, just one software installations per CPU target. And you can see that it's been, well, that's in that little plot from November, that's been a fairly linear increase. So the numbers are going up and up. And very soon, we're also going to have a really cool, searchable table where you can look up what is the stuff that's already there. It's going to make it, at a glance, you can just go to that page and see that's coming very soon. So that's going to make it easier. So part of the software that's already there is the stuff that's needed by the scientific partners in multi-xScale, but it's, of course, very much not limited to any new additions. If you have easy configs and it would fit and meets the criteria, then you could try to get it on easy. Of course, it does have to, as we just discussed, as a rule, build for all of these CPU targets, and we're focusing on the more recent tool chain, so it needs to be compatible there. But beyond that, if it works, then as a rule, it's welcome. So now I'll go a little bit more in depth into what are all of the little steps that take part of this, and the screen will be full, but it really isn't anything complicated. So say if you start with, as a contributor, you want to add some software to Easy, so you go to the repo that I mentioned before, and you say, well, I'm going to create a PR, I'm going to add an easy config file to an easy stack file. That's going to be what I want to have. So you need to start from an easy config file, and I'm going to open a PR. So from the moment you open a PR, it's going to become visible, and from that point on, The reviewers can look at what was added and say, okay, this looks like something we want to see if we can build it. So they can give some commands to a bot which is basically a GitHub application. I'll go a little bit more in detail on the bot later, that can trigger the builds for whichever CPU target was requested. In the ones that you can see over there. And so the builds will start, and if everything goes well, they will also be tested, of course. And in the end, you will end up with the software installation tarballs. So from that point, if all of the CPU targets, if the builds for all of the CPU targets worked correctly, the tarballs can be put in an S3 bucket. From which point their cron job is going to pick them up and move them onto the Stratum 0 server. So from this point on, from the perspective of a contributor, someone who's just adding software to Easy, you won't see this part happening. This is happening behind the scenes. But what's happening is the tarballs get placed there, and automatically a PR gets opened into a separate hidden repo. The staging repo, where there's one last check of a smaller group of maintainers that can see, okay, these are the tarballs, this is some metadata that's associated, so can look up at the history of how the build works and so on, and then make a final seal of approval, say, yes, okay, we're going to ingest it into the Tractum 0 server, and we're going to deploy this in Easy. And this is also an automated process. And then soon, we're talking hours rather than days, it becomes available and seamlessly available to anyone who has Easy on their systems, be it in a laptop or an HPC and so on. So that's kind of a broad overview. Of course, getting this to work requires, we're using EasyBuild, but it requires that we set up the environment in some specific way. So I think you're all familiar with using EasyBuild, but there's some aspects of the configuration that need to be taken care of that happen. As a contributor, you don't really need to necessarily think too much about this, but if you're looking into it, it's nice to keep in mind. So because of the compatibility layer, the fact that we're building in this Gentoo prefix environment, we have to set our path, the system root to have this working. We have to filter the dependencies of stuff that's coming from the compatibility layer. We also are using EZ stack files, so currently, still for now, I guess we have the experimental flag on, and then the builds happen inside a Debian 11 container that look at these, and from there the EZ stack files are going to get built. And there are also some hooks that allow us to address the host injections of the specific things that need to be injected from the host OS, and tailor some things that are specific. Maybe for some specific software, there's a hook that needs to be added to address a certain test or a part of the installation that needs to happen at that level. So that's sort of the easy. Oh yeah. Yeah. Maybe the sound was.
Oh no. No, keep going.
Yeah.
Sorry.
No worries, no problem.
I opened YouTube and it told me the stream had finished.
Yeah. No problem. Okay, so then. So that's kind of the setting up the settings of the environment in a way. And the environment and the call stack kind of looks like like this. So once a build starts, the bot is going to call this script that lives in the software layer. And that's kickstarts the build. It starts, then goes in layers. It starts the container. It sets everything up in the compat layer. And then in the end, something gets called that actually will call EasyBuild and build everything with the required settings and so on and so forth. So it's quite nested, but it's kind of an overview of what is happening inside. So now it's I think a good point to talk about the bot, as I've been mentioning it a lot. So what exactly is the bot? It's as I said before, it's a GitHub app that just is listening to these PR events, so meaning opening PRs, labels being added, and comments. So it's important to note that for most of the interaction with the bot, you need to have permissions. So that would be first, if you remember this first circular slide, the when the reviewers say, okay, well, let's build something, you need permissions for that. But essentially, as far as actually giving the commands goes, that's literally just writing a comment on the PR that will trigger a build or show you the installation. So do you make comments like this? I'm going to demonstrate this later, so don't need to go into it in too much detail. But you basically say, oh, I want to build for this repo in this architecture, and it can combine multiple commands, and it will do it. Or I want to add a label to deploy it, and then it will trigger this process as well. So there's also a lot of documentation. It's important to say about on the bot, on our documentation, and the bot itself. The code for the bot lives in that repo over there, also in the easy org. So the bot is running in there's 2 instances of the bot running in 2 cloud clusters in AWS and Azure. Azure is just gonna start using it to build for Zen 4. Well, I mean, it's already working, but to get the process going. But it's interesting to note that the bot itself was designed and built to be agnostic to Easy, so we use it for Easy, but you can and quite easily get it working on a particular system. So that's I was fairly quick to do in Groningen, for example. I just grabbed the bot and configured it in such a way that we could just also trigger builds from PRs with our specific build container. So you can adapt it to your needs and say, okay, I actually don't need a deployment stage or whatever. And that's a fairly easy thing to do. And there's a ton of documentation. It's really detailed and how to start it up. And so that's quite nice, I think. And the bot then itself is built up of basically 3 if you count the webhook service that's listening to things, but is essentially something that just handles the events, that says, okay, well, I've figured that I received notice that there's a PR, I'm going to write a comment, well, I'm going to listen to comments, and then another part, a job handler that actually will start Slurm jobs and looks at the queue, reports it back, and checks back things, basically what's happening. Okay. So now I'm going to move to the demo before I talk about the rest of the stuff, because it's fast, but it takes a few minutes. So hopefully things will be building while we do that. So let's say that maybe I can increase the size a little bit. So this is my fork of the software layer. So I'm just going to show you basically what I did. Inside the software layer repo, there's a directory called EasyStacks. And then let's say, okay, I want to add something for 2023A using EasyBuild 4.9.1. So we have an easy file there. And what I added was a bioinformatics tool, this SAM tools that we've already heard about. So now the idea is we just need to make a PR with these changes. So this is the wrong repo. So now I am on the Easy repo, the software layer on the Easy organization. I'm going to say I'm going to open a PR from the fork that I just showed you, and yeah, it's basically going to add that line in that PR. We follow this. I'll show you here. I've already tried this before, hence the notice. Let's see. So I'm going to create this, and then we try to stick with. Why am I looking there if there's a screen in front of my face? So I copied it here, but we basically try to follow with a format just to make things a little easier to track. Not that you can change that later. And said, okay, we're going to add SAM tools 118 for 2023A on our repo. And let's make this a pull request. So then we do that. Then, okay. So immediately trigger some CI that checks for a bunch of things. If things are working, how for the container, and it will also an important one as a contributor. You'll want to see that the one for missing software, that in the end you'll want to have this be green because your new software will be added and there won't be anything missing. In this particular case, we don't have anything with a lot of dependencies, so the bot immediately figures out that there was a PR opened, and it'll report, okay, look, there are these two instances, one in AWS and one in Azure, and I'm configured to build for all of these, for all of these architectures and for these repos. So in the more usual case, what we start doing, let's say we start building for two of the two generic arches. So you do that by running a comment. So again, here this is a place where you would need permission. So if you're coming from outside of the project, you would open the PR, you can talk to us, and then we would trigger the builds. But we usually start with triggering something for ARM and for x86. And basically the format is the command for the bot. So we build for the EasyIO 2023.06 software repo, which is our production repo, and then you give it a notice of what the architecture is. And once I make this comment, the bot figures out, hey, okay, something happened. There was an update. I got this command from this person, and immediately it's going to queue up jobs that are going to build the software. Hopefully we will have the tarballs for this software. So normally we wait for one or two to work to see if there's anything. It's very easy to forget something, maybe a detail, maybe something wasn't merged properly or whatever, just to see if stuff is working. And then we can give all the other tarballs to run. So this doesn't always, there's always problems when you're installing software. So there are instances where this doesn't work. So I'll just show you an example here of something that I tried adding. There was something wrong. Initially, this was adding Qt5 a while ago. So see, there was a merge conflict that Kenneth pointed out to me, and we started the builds, and then in the end, the bot said, okay, well, this wasn't working. That's okay. Bob, hi Bob, I think he's watching, kindly pointed out that, hey, look, we actually already figured this out, so you can include this from this PR and start the builds again, and then things work. So just to say that, yeah, things go wrong, but then the whole point is that there's a community that is there, and we're there, a part of our job to help you and to figure this out. And sometimes it takes a little longer, sometimes it's very straightforward. So now this is, the jobs are queued up to launch. So what I'm going to do now is I'm going to go back to the presentation, and while this runs, and hopefully by the time I'm done with my slides, we can check in back to see what the results look like there. Let's see if I can. Okay. So, as I just mentioned, we want to foster this sort of community participation. So this is just one example of software for radio astronomy. This was a community request via SURF, who are one of the regional center partners for this project, and they basically wanted to have to use Easy, and they needed a bunch of software for that. And they basically said, okay, well, we've actually made some Easy config files. We want to get this going, so they opened an issue on our support portal, and then there was a conversation to see how we're going to do it. This is how the process works. This is what's going to happen. And then in the end, without major issues, there were a few kinks along the way, but everything worked out, and the software was merged and it's ingested and it's available. Okay, so it's also important to say that not beyond just the community portal, the documentation is quite extensive, and we try to keep it up to date. There you can find it's divided into, it's organized in such a way that you can point it to, okay, if you're a user, this is maybe what you want to start looking at. If you're contributing, this is a good place to look into, or if you're maintaining, and so on and so forth. So there's instructions on how to add new software, where do you get help, what do you do when you have harder builds that are failing that you really need to look into. And then, of course, beyond the documentation, as I mentioned, there's the support portal, and then there's also the Easy Slack. So let's see, I think the next step I was going to show is the ingestion step. So maybe before I do that, we can check. Oh, no, that would be here. How this is looking. Or still in the... Let's see if this is a browser cache. yeah, it takes sometimes it might take a couple of minutes to start, but yeah, the job will be released soon and then it will start building. But yeah, in the meantime, I can give you a sneak peek behind the scenes. So this is at the last stage of once everything has been built and been put into stratum 0, before things are actually ingested. This, as I mentioned, there's an automatic PR that gets opened to actually ingest the tar balls to make them available for everyone. So this looks like a PR in this way, and with all the metadata information and the software tar balls, and then this smaller group of maintainers can say, okay, yes, we approve this, or we need to look into this more or less, or we're going to merge this or not. So let's see how this is looking now. Okay, so if it's on the way. So I will show you a little bit from a past PR, and then we can revisit it later. Once build is completed, you might see that things succeeded. So you'll get a table with the information on the job and how things went. You can see more detailed information and why the bot things succeeded, and see the list of the tar balls in this the modules that were generated in this particular case. So you can get a sense of how things are going. And once you have the builds for all of the architectures, we can tag, I'll show this also on this PR. We would tag this in this case as ready to deploy. And from then on, with this deploy label that maintainers can add, then this is what kickstarts things from going into the Stratum 0 server and then going through that last round of review. So you as a contributor will basically, if you're doing it at this level, you'll see from this point on, your job is done, things are okay, and you're good to go. One last look at, okay, well, the jobs are running now. So we should be, yeah, it's going to take a little while longer, but things are in motion. So I will move back to my slides, and then during the questions, maybe we can check in again. Yeah, so that was pretty much what I wanted to tell you about, to show you how the contribution process works. Mention again the funding we get from UHPC in the multi-skill project, also from the credits from Amazon and Microsoft for the clusters. Yeah, and on a personal note, also thank you for everyone on the EasyBuild project for making it so fun and an enjoyable place to collaborate in. And that's pretty much it. I'll leave you with the links you've seen before for the repos and the website, documentation, and so on. And yeah, if there's any questions?
Thank you, Pedro. Any questions for Pedro?
Failed builds and stuff like that. Yes. How is the cleanup done?
It doesn't
happen. I just saw one.
Yeah.
No, in failed builds, so what happens behind the scenes in the cloud, that there's the bot will start the jobs, and you'll get whenever it does so, it clones the PR, and it gets sets up the environment. And I think, does the cleanup happen automatically? I'm not sure actually. No, right?
No.
We have to.
But it just dumps a bunch of stuff on disk per build separately. Yeah. And then eventually, for now, that's a manual job. So if you see the disk running full, we clean up stuff of merged PRs. But eventually that will have to be automated. Yeah.
My question was actually, if you get the tarball in the bucket and you decide this is not going to go in, do you clean that up?
From the bucket or
whatever garbage it has left in the tree?
Yeah, I think for closed or merged PRs, we just chuck stuff. I mean, worst case, you have to redo it. From the bucket, I don't think we remove stuff from the bucket up until now. There's no, the cloud is infinite, so and we're getting
start raining crap.
we're getting sponsored credits from AWS and Azure, so we have literally zero worries about cost up until now. Maybe that will change, but so we're not really paying very close attention to that currently. But as an end user, you never see this anyway. Yeah.
Excellent.
In that list of CPUs, the Intel ones are so Skylake, but I didn't see any Ice Lake. Are you planning to do Ice Lake as well? Or is that currently a little bit difficult, to put it like that, because you don't have access to it?
Kenneth is the one.
We haven't bothered up until now because I think the extra performance benefit is limited. The biggest difference is making sure you're using AVX 512. There are a couple of extra instructions even in Cascade Lake already, I think. Like there's VNNI, which Cascade Lake has, which Skylake doesn't. I'm not sure Ice Lake adds additional stuff.
Yes.
It does? Okay. So we could, but currently we haven't seen a strong enough reason for it. We do have access to it. Like this is one of the reasons we're building our stuff in the cloud. It's very easy to get access to even the very newest hardware, like the AMD Bergamo CPUs. Almost from day one, you can get access to them through the cloud. So that's very helpful. It's very flexible, and they're very early on getting new hardware. Yeah, that's one of the reasons. So it's not the hardware access, it's more like what makes most sense in terms of effort to start supporting. We're now looking at Zen 4 because that's AVX 512, and the current AMD builds don't have AVX 512, so that's a big factor. And especially now that everything is automated, we could expand this as far as we want to. We now have 8 targets. With Zen 4, we'll have 9 targets. Whether it's 9 or 20, that's mostly a detail. Yeah. We're also looking at ARM. We now have Neoverse N1, Neoverse V1. So that's Graviton 2, Graviton 3 in AWS. NVIDIA Grace is Neoverse V2. So we're definitely going to do that. There's A64FX as well, which is relevant for the big Euro HPC system in Portugal. That's definitely a target. So we're already looking at other stuff. And in the end, at some point, I guess we'll be running up to 20 CPU targets. And we're just making sure we have enough automation in place to deal with that. Now, the more stuff you build for, the more likely there's a chance that it doesn't work for one of them. And then you need a way to deal with that as well. So it does raise questions. And yeah, it's a matter of where do we focus our effort currently.
I remember from the Computer Canada items, they talk about that they sort of fail back onto a previous generation of software. So
Yeah. So if you're running easy on an Ice Lake, it will work fine. It will just use the Skylake binaries. Yeah. So it auto detects and it falls back to whatever is the best match that it can offer you. Yeah.
Would it do the same if you did build an Ice Lake stack, but one bit of software failed to build, because that's the
not currently, but that's something we could do. Like we could let's say only build PyTorch optimized for Ice Lake and just fall back to everything for Skylake for everything else. We don't have that set up currently, but that's one thing we could do, and that would limit the efforts quite a bit. Yeah.
Because that also then gives you an option if it's the PyTorch bit that's failing, but everything else in the stack is optimized, and I particularly say NumPy or whatever, you can have that. Because effectively, this is what we're doing on our cluster: is we fall back generations of CPU architecture in various different ways. For that exact reason of, well, I've got Sapphire Rapids nodes that turned up recently, and I have nothing built directly on them because nothing builds. None of the older tool chains we had deployed builds on them.
Yeah, this mix and match thing makes a lot of sense, but it's also, you have to structure that and make sure that it's all working. So it's extra effort. It's just easier to do a stupid fallback to whatever works. Yeah, I think eventually we'll have something like this. Yeah, and I suspect, especially in the ARM space, we'll need that more, because as soon as you go to ARM chips that have these SVE vector instructions, we do notice that not too many people are actually testing stuff on those. So whether it's a choice between you build something with SVE support, and if it then doesn't work, you don't offer it, or you give it the fallback binary instead. At least giving something that works is better than not giving it at all. So in that sense, doing the fallback is. We assume if it passes the test suite that it behaves, right? That's, I mean, we need to rely on that. Yeah.
In the demonstration, you showed the FOSS software toolchain. Are you going to be supporting as well Intel toolchains, or?
Are we? It's only for free open source stuff, right?
It's not exactly open source. So that's a conversation we need to have with Intel. We need to check the EULA. What are we allowed to redistribute? That's really what it boils down to. We'll get to this a bit this afternoon as well with the GPU support that we have currently, where we have support for NVIDIA GPUs in EasyBuild already, but we only ship the CUDA runtime, not the compiler. Because EULA-wise, we're not allowed to ship the redistribute the compiler. I'm not sure if we'll need to do something like this for Intel, but I do know it's possible. So if we only need to ship the runtime, that's possible. And then the compiler will not be there, so you won't be able to compile stuff yourself straight from Easy, but you could just install the compiler on the side with EasyBuild and then build stuff on top of Easy using the Intel toolchain. So it is possible, yeah. Legally, we have to make sure we don't shoot ourselves in the foot, right? If we annoy NVIDIA, then yeah, we don't want to do that. Same with Intel.
You just install the Intel compiler in your site, part of, as I'm doing.
Yeah. You can mix and match things. That's what we're doing with CUDA as well. So we ship the CUDA runtime. We're shipping not a lot of GPU software yet. It's mostly test things like CUDA samples and OZU micro benchmarks. Eventually, we'll ship GROMACS and PyTorch and TensorFlow with GPU support in Easy as well. But as soon as you then want to start building something yourself with CUDA support, then you need to do a small side step, which is well documented. Yeah. We'll get to that a bit this afternoon. I'll try to do a demo of that, of how that works currently.
It also works well just installing the CUDA part in your site installation instead of using their step.
Yeah.
I did that.
Yeah, that works too. Yeah.
One very simple question: to open a PR, should I have already been accepted as an EasyBuild easy config, or
at the moment you need to have an easy config available. That
in the easy config repo or just somewhere?
No, ideally yes, right? But it doesn't. Yeah, it needs to be.
And just an open pull request, or you should be already accepted? That's the.
Is that covered in detail in our policy? So we have a contribution policy that says you have to meet these points for that software to be included in Easy. We do allow you to open a pull request for something that's in an Easy config pull request, but not in an EasyBuild release yet. While the bot is building, it's fine if that PR is not merged yet, but we will only deploy it in Easy if the PR is merged. So it's like, as long as you're testing, it's fine. But when you actually want it in Easy, then the PR has to be merged in EasyBuild as well. And that's related to security. So you don't shove in stuff that's malicious. Yeah. So I think we're reasonably flexible there. Yeah. We're not very strict. And eventually, and that's something I always mention, is we're not stuck to EasyBuild for building software. We could do stuff with SPAC as well. The main reason we're using EasyBuild is because we added features in EasyBuild that help us a lot in Easy, which I think are not in SPAC yet, but they could be implemented there as well. So like building on top of this compat layer and these kind of things. You could give us a bash script that compiles stuff as long as you're sticking to that compat layer. In theory, that's fine. I'm not sure we actually want to go to that road, but yeah, we could. Any more questions?
So my EasyBuild maintainer hat going on at this point. If Easy becomes popular enough that there are a lot of contributions at that end, a lot of contributions of people trying to get software, at what point will Easy help merge them the EasyBuild end? Because
we are already.
Yeah. I mean, I know you are, but I mean, it's that.
There's a couple of maintainers. Alan is definitely one of them. Bob in Groningen is one of them. Me. Lara will eventually get maintainer rights probably as well if she wants to. So and for everything that's relevant to Easy, you'll see activity from EasyBuild maintainers there as well. So we're not going to push that to the current maintainers. No.
Yeah, it's very much already what you see happening. So say in that example that the SKA thing where it was a kind of collaborative process between the people who requested it and the Easy side to get the Easy configs and everything up and running. So that was
And yeah, it sounds like it could have a negative impact on EasyBuild, like more work. I think it's at least currently it's actually having a positive impact because it's bringing in more people.
Yeah, it's whether it just brings in the conflict of the Easy wanting a very specific direction that the rest of the maintainers, you know, or focus on a lot of things that are relevant to Easy because of the scale of machines it's been or type of machines it's been deployed on, which is, you know, it's always the conflict, but you know, it's the same thing that others maintainers have of software that we're, you know, at the EasyBuild end of, the software that we're really interested in, and the software. Because it's a bit like I almost always look at Adam's PRs really quickly, because if his users have asked him, he's PR'd it. One of my users is about to ask for exactly the same bit of software in about 5 minutes' time.
So there is already, I mean, I think every EasyBuild maintainer focuses on the stuff that's mostly relevant to them. So there's a lot of that already. No, so that's something we definitely need to keep an eye out for. If you see that happening, like if there's too much of a shift towards stuff that's only relevant to Easy, the other maintainers should just speak up and say, this is going in the wrong direction.
Yeah, and I think it's also the sort of impact allowing options in framework and fixing easy blocks.
Yep.
That help Easy, but don't make it EasyBuild as an end user harder to use.
No, yeah. Well, yeah. If we need stuff for Easy, it will be optional in EasyBuild, and we'll have to flip it on in Easy. But that's fine. Yeah. No, I'm actually not too worried about that. And actually, in the end, in Easy, the goal is to install everything that's open source and supported in EasyBuild. We'll install in Easy because there's no reason not to. So to some extent, the overlap is going to be pretty big in terms of interest. Yeah. We have a question in Zoom as well. Or just
no. Thomas is answering or adding additional comments
if
you want to read them all. But basically, I think most of it's what that you then said as.
You said that Easy is not tied to EasyBuild. So would it support something like Nix or Gix recipes perhaps at some point?
Yeah.
We could if someone was to work for it. Yeah.
Okay.
Would
you like the microphone back?
Yeah, I'm thinking how to answer that. I mean, we're not tied to EasyBuild. We're, like I said, bash scripts in theory at least we could allow if we think that's of importance to the project, if that would help Easy, we can just take bash scripts as long as they do what they have to do. That's fine. So whether it's Nix or Spec or Bash or God knows what, I don't know. For now, we're just sticking to EasyBuild because we have enough work to do. It's a tool we control basically. We decide what goes in there. That's very helpful. I'm not sure with Nix. I mean, I don't think we want to use yet another compat layer, right? It will have to be on top of what we already have. I'm not sure that's even possible with Nix. If you can convince it to use what's already there, I have no idea. Yeah. I also, for Spec, I have no idea what would be necessary in Spec, how much work that would be. I know someone was looking at it at some point, but I don't know if it actually materialized or... So yeah, we're definitely keeping that door open. I think that's also in our best interest to make it clear that that door is open. Yep. Okay. Yeah, it'll be more easy fun in the hands-on and in the yeah. You want to add something on the builds or?
Sorry, what do you mean?
Oh, I thought you were on.
Oh no, I just wanted to say that. Yeah, look, it built. Yay for
working.
this one. So now this is where we would start the more builds. Yeah.
Yeah, and Thomas is making a good comment in Zoom. Like building on top of the compat layer is one thing, and ideally And I think especially for spec, that could be a factor. It should reuse stuff that's already there. Right. So if there's a CMake there, spec shouldn't build its own CMake again. But and there are ways to convince it to use like external stuff. Yeah, Nix lives very much in its own world, right? So that's not going to be trivial. Yeah. Doesn't mean it's impossible, but somehow you have to make the effort of making that work and the way we think it should work. Yeah. So policy-wise, there are some things that we're not easily going to divert from. We're not going to have 10 builds of CMake for the same CPU target just because it was done by different tools. That doesn't make sense.
That's it, I guess. Yep.
Yep. Thank you, Pedro.
Thank you. Stop the share. Thanks.